Good morning, everyone. Today we are going to continue with the chapter area and perimeter. You already have learnt about area and perimeter of rectangle and squares. Now today we are going to learn about area of parallelograms and triangles. That is the next subtopic in the chapter. So first we are going to learn about parallelograms. Do you have some idea about parallelograms? Parallelogram looks like this. A parallelogram is a four-sided figure in which the opposite sides are parallel. So this side is parallel to this side and the other side will be parallel to the opposite side. Like here in this figure, we have this side parallel to this side. So this is a parallelogram. Now in this, what will be called as base? Because when we calculate area, so the formula of area parallelogram is base into height. So what will be base? So that you have to understand. Base is the which side of this parallelogram. So here you can see that base is this. So base is this side and height is the perpendicular distance in between the two parallel sides. So parallel sides are which one? One which is highlighted and the other is parallel side is this. And then this will be the height, the distance between the two parallel sides. But here we can also take the other two parallel sides also as base. So in this figure, if I take this side as base, suppose I take this side as base, then what will be the height of this parallelogram? So that you have to understand here. So if I take this side as base, then the height will be this one. So the perpendicular height is corresponding to the base. So if you take, suppose this side as base, then this is the corresponding height. If you are taking the other side as base, that is, you are taking this side as base, then this will be the corresponding height. That you have to understand. So the height will be the corresponding height to the base that we are considering. So any side of the parallelogram can be taken as base. Now the next figure is triangles. Now in triangle also any side of the triangle can be taken as base. For example, in this figure, this is taken as base, then the corresponding height is this. But suppose you change the base, you take any other side as base. Suppose you are taking this side as base, then height will also change. Then height will be the corresponding height from the opposite vertex to the base that we are taking. This will be the 90-degree line, that is a perpendicular, so height will also change according to the side. Now area that is represented by A is half into base into height. So base we represent by B, so half into B into height is represented by H, so half into A equal to half into B into H, that is the area of any triangle. So it's a general formula for area of a triangle. Now open the second exercise, that is exercise 16.2. Open your books, look at question number 1, second part. Find the area of the following parallelogram. So here the figure is given in the question, a parallelogram is given, and figure is given in which you are given one side. So this side we can take as base. Then what will be the corresponding height? This is the corresponding height then. As I told you, the height should be corresponding to the base we are taking. So area of parallelogram formula we apply. So area of parallelogram is base into height. So since our base is 2 and height is 4.4, so it is 8.8 centimeter square area of parallelogram. Now look at question number 2, third part. Find the area of the following triangle. So in this question also the figure is given, a triangle is given. Now here if we take this side as base, which is 4.5 centimeter, then height should be from the opposite vertex, that is this vertex. So from this vertex height should be taken, so height will be this. So that is why 6 centimeter is the corresponding height. So here if we apply the formula, we get area of triangle equal to half into base into height. Base is 4.5, so half into 4.5 into 6, that is 13.5 centimeter square. Now look at question number 5. In the adjoining figure, ABCD is a parallelogram whose two adjacent sides are given 6 and 4 centimeter. If the height corresponding to the base AB is given, find the area of the parallelogram ABCD. And the second part is the height corresponding to the base AD. So in this figure, one side is given, actually two sides are given. If you take this side as base, you should take the corresponding altitude, and if you take this side as base, height should be from the opposite vertex. So here this can, so here base AB is given 6 centimeter and corresponding height is given 3 centimeter. So first we will take base AB 6 centimeter and height as 3 centimeter, and we'll find the area parallelogram ABCD. So area parallelogram ABCD is equal to base into height, that is 6 into 3, that is 18 centimeter square. So first part, area parallelogram is 18 centimeter square. And second part, they are asking height corresponding to the base AD. So that means AD becomes the base. How much is AD here? AD is 4 centimeter. So this is 4 centimeter. So we'll take the corresponding height. Corresponding height means height from opposite vertex to this base. So this we have to find. So let this height be. So since this is not given, let it be h. The missing height to be h. So again apply the formula of area parallelogram, that is base into height. But now the area is known because it is the same parallelogram, so area will be same. So area is 18 centimeters square is equal to base, which is 4 here, and height here taken as h. So you can calculate h from here. It is 18 divided by 4, that is 4.5 centimeter. That is the height corresponding to the base AD. Now look at question number 7. If the base of a right angle triangle is 8 centimeter and the hypotenuse is 17 centimeter, find its area. So here, as you can see, neither the height of the triangle is given, base is of course given, but height is not given. Instead, hypotenuse of the triangle is given. So now you must recall Pythagoras theorem, which you have studied, because in a right angle triangle we can apply Pythagoras theorem, as you know. So here we are given the hypotenuse, we are given one side, so we can take that as base, and this perpendicular we can take as height. So in right angle triangle, actually the two sides can be taken as base and height. So that is a thing you have to understand in a right angle triangle. So this, if you take this as base, this will be the height of the triangle. So two sides of the right angle triangle only become base and height. You don't need a separate height because it is already a perpendicular. So this will be the height. Now let us find height because that is missing here. So we can apply Pythagoras theorem here to find the height. So according to Pythagoras property in this triangle, hypotenuse square equal to h square plus 8 square. So here 17 square equal to h square plus 8 square. So if we calculate uh, 17 square, just change this. This is actually 8. This should be 8. So h, not b. This is h. So we get h square equal to 17 square minus 8 square. So we calculate this. So we get h square equal to 225, and hence h is under root 225, and you know how to find the square root. So we will factorize it and we get h as 15 centimeter. So we got the missing height. Now simply we can apply the formula of area of triangle to get the area. So area of triangle is half into base into height. Base is 8 here and height is 14. So if we calculate this, we get 56 centimeters square, the area of the right angle triangle. Now look at question number 10. In that ABCD is the rectangle of size 18 centimeter by 10 centimeter, and inside the rectangle a triangle is given, triangle BEC, where angle A is given 90 degree and EC is 8 centimeter given. Find the area of the shaded region. So you have to find the area of the shaded region, that is this region, one which is painted blue here. So this area you have to find. So as you can see, this area, the shaded area, can be area of this rectangle minus area of the triangle. So here actually if we subtract the area of triangle, this triangle, from the rectangle which is colored blue here. So the blue colored rectangle minus the red colored triangle, then we get the area, remaining area or the area of the shaded area. So let us calculate the two areas. But here one thing is missing. What is that missing thing? You have this side missing from this triangle. So can we calculate that? Since it is a right angle triangle, so we again apply Pythagoras property to calculate the missing side. So we apply Pythagoras property, BC square equal to BE square plus CE square here. BC is given 10, BE is also given, in fact C is given. Let BE to be x. So BE we have taken as x. So x square equal to 10 square minus 8 square, which you will get x square as 36 and x equal to under root 36, that is x equal to 6 centimeter, and finding square root of 36. So that is actually B. So the missing side B we calculated as 6 centimeter. So now this side, now B has come 6 centimeter, right? Now we can find the area of triangle, this triangle also, since the base, the actually the sides containing right angle are now known. So this we can take as base, or this as base, and the other side as height. So 8 and 6 centimeter become the base and height. And in rectangle, already base and uh, height are given. So we can calculate area of the two figures and subtract. So area of the shaded region is area of parallelogram ABCD minus area of triangle BC. You know area of parallelogram is base into height and area of triangle is half into base into height. So base into height. Uh, Actually, here I must mention that rectangle is also a kind of parallelogram. So either you apply base into height or you apply length into breadth. In both cases, the formula remains same. So it is 18 into 10, the area of rectangle or area of parallelogram, whatever you say. And triangle BCE is half into base into height. So half into 8 into 6. As I told, base and height are 8 and 6. So it is 180 minus 24. That is 156 centimeter square. So area of the sheet region in this figure is 156 centimeter square.